Well, in this first question, what we're looking at is that ionic equations tend to be really fast. Question B beats out D because B is simpler as well. Now, sometimes you're given a formula equation, so don't forget to look at it. Hydrochloric acid and sodium hydroxide, the net ionic equation is aqueous ions. Same with precipitation involving lead nitrate and potassium iodide. So you need to look at that formula equation and then maybe take it apart. A is two gases, and the fact is that is pretty fast. C is solids, and it's slow, generally speaking. Now, question 2 is really about stoichiometry. Yes, we need to calculate the rate of H2O2, but it's really about using stoich to find about the nitrogen. So that's a 1 to 2 mole ratio here. Notice the wrong answer is one of the choices. Question 3, hydrochloric acid is a reactant, so it's got to be going down. It's the only one, that's C. A actually could well show the product's zinc chloride or the volume of hydrogen going up. Question D really shows a spectator ion, but it couldn't be used to find rate because it doesn't change. Question 4 also is about stoichiometry. Again, we do calculate a rate of iron production, but we need the mole ratio here to connect us to Fe2O3. Now, in question 5, its change of acidity is important. The point I want to make about this is there's so many ways to talk about it. Decrease in hydronium ion concentration, or hydrogen ion, which is the same thing, it's just a different notation, or an increase in the pH. Also, total mass never works to find the rate because total mass never changes. But in an open system, and if there's a gas produced, the mass will decrease. In this next one, again, we're looking at rate. We're looking at controlling the rate, not measuring it. And temperature always increases the rate. There's no exceptions to this. Now, B is no good because no gases involved, no pressure changes. C and D, very important. Products have nothing to do with determining rate. In question 7, surface area is related to heterogeneous reactions such as oil and water or HCl and zinc. Hydrogen and oxygen gas, or hydrochloric acid and sodium hydroxide aqueous, there's no surface, so surface area is not important. 7 is also about surface area. 8, highest temperature will be fast, which is why 2 is the slowest, and highest concentration will be the fastest, which is why 3 wins out. Now in this next one, notice the question talks about the average. What you don't do is calculate the rate 3 times and then maybe add them up and divide by 3. No, just for the average, just take the beginning points and the end points and subtract them, as we do with a slope, which is really a kind of average as well. Don't worry about the negative sign, you can just throw it away. It has no impact on the marks. Oh, and look at this mole ratio, 2 to 56 here. Well, this next one involves mole ratio, but don't forget to convert grams to moles first, that huge 394 gram molar mass. Then use the mole ratio and you've got your answer. We're almost done. Having a look here at this question, it asks, well, how much is left? Well, really it's about how much gets used up, and then you subtract it to find out how much is left. So this is all about how much gets used up, and it begins with hydrochloric acid. The rate times the time can be found from the rate formula, and you do that for hydrochloric acid. Then you've got a mole ratio, conversion of mass to moles, and then you can subtract to get your answer. And finally, once again, we modify the equation to read as time is amount over rate. But first, remember what the rate is. You're starting with rate of oxygen, and you need to use the mole ratio to convert that to water. And then, again, we use that formula and divide. Well, that's it. I hope you like this.